Okay, boys and girls, this is our very first assignment. This is assignment Unit 0, Assignment 1. Now, a thing to keep in mind while I do my assignments and things like that is through the Canvas program, the problems that are assigned are completely randomized. And so I might be doing problems that might not appear, like, for instance, my number 1 might be your number 8 or something like that. It could be a different problem. Or they take these problems from a big pool of questions. So I might be doing problems that you don't even have whatsoever. All right, so you might, like, my question 1 might not even appear on your assignment, or your assignment might not have problems that I do on my videos here. However, they are going to be somewhat similar. Like, they don't venture into a different topic or anything. They're all centered around the same core idea. So if you can do my number 1, I'm assuming that you would be able to do your problem number 1. They would be similar enough that you can take the concepts. Yes, the numbers might be different. The process might be a little bit different. However, the problems are similar enough that you can take care of what you need to take care of. Okay. So with that being said, I'm just going to kind of walk and talk through this assignment, showing you how I take care of some of this stuff. So originally this thing is g of x. So notice what is taking place. This 12 is taking the place of this x. So that's what we have to do in the g function, is make all of the x's in the g function 12. So wherever you see an x, we make it the number 12. All right, so the first thing that we're going to do is we are going to put a 12 in for any x that I see. So this is 2/3 square root of x, okay, which is now going to be the number 12 minus 5. Push come to shove, you can type that into the Desmos program and get an answer. Push comes to shove, that's what you can do. All right, so I need to do the problem on the inside of this first, which is 12 minus 5, which is 7. Okay, square root of 7 is nothing good. So I'm at the point where I pretty much have to type this into my calculator. So I'm going to be using a different calculator than what you have, but it's still pretty similar, and I'll get the same answers. All right, so I get this answer 1.76383, blah, 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 blah. All right, we need to round our answer to the nearest hundredth. All right, so on decimal places, we start with the tenths, and then we go to the hundredths, and then would come the thousandths, and then the 10,000ths, then the 100,000ths, then the millionths, et cetera, et cetera. All right, so 10 hundredths. Hundredths is the second decimal place. So in our answer, we're going to cut our answer off at that 6. This 3 is a small number. So because that's a small number, we do not round the 6. Otherwise, the 6 would get rounded to 7. So our answer in this situation is 1.76. If you need help rounding numbers, we can talk about that in class. All right, evaluate the function. Here we have h of 3. So again, what I do is I go through this equation, this function that I have, and wherever I see an x, I put a 3. Okay. This top answer is 2 times 3, so I do the multiplication first. So 2 times 3 is 6, and then 6 plus 1 is 7. On the bottom, I have 3 minus 3, which is 0. All right, so here we have a 0. And my trick to know what the answer is when a 0 is involved with some sort of fraction, right? And I'll write two little brief mini examples here. Say I have, in this first situation, 0 over a number. When it's over, all right, I can write the word over. Here, on the second situation, I have the 0 under. So I write the word under. How does that help me get what the actual answer is? Well, when it's over in the left hand, in the left example, the answer is 0. Over, it looks like 0 if it's over. If it's under, then it's undefined. It's under, so it's undefined. So this one, yes, it is under, so this is an undefined. Okay, here we have f plus g of x. And then they give us this f of x and g of x, et cetera, et cetera, et cetera. Don't be frightened by the way this looks, all right? All this is this is going to be f of x plus g of x. That's all that is. F plus g of x means f of x plus g of x. So I encourage, oops, sorry, I should probably keep that up there. I encourage you to, when you do this, put these things in their own unique parentheses. So for instance, I begin with f of x. So I begin in parentheses and I write down what x is. Plus, and then here comes the g of x, and now again, I put it in its own unique parentheses. Okay, because this middle symbol is a plus, it's all good. All we are doing is we are physically adding these things. So again, like terms, so x squareds go with x squareds. So I have -1 plus -4, or aka -1 minus 4, so that would be -5 of those x squareds. X's go with x's. Again, because the middle is a plus, we don't have to worry about any funny business going on. So this would be 7, positive 7, minus 8. So that's -1. You don't have to have the -1. You could just report that as a minus, but -1. Last thing is the normal number with the normal number. And so this is +1 plus 2. So that comes out to be a +3. And this is written in quote-unquote standard form. Okay, similar to the above problem, this next problem, problem 4, is f minus g of x. So that would be f of x minus g of x, and the order does matter. All right, again, I really encourage you to put these in parentheses, especially with a minus. It's going to be crazy important that you do this. Okay, here's what we get. So we have f of x minus g of x. Okay, now why the parentheses are crazy important here is because this middle symbol being a minus makes things a little bit more difficult. Yes, it's still an addition, subtraction kind of problem, but what I'm going to do is I have to take this minus and kind of like distribute it into that big parentheses. All right, so this will be a plus, and it'll be a -x and a +9. So upon the rewrite, this is a 5x plus 7 minus x plus 9. So all of those symbols had to change. But after I do that, we're all good. So x's go with x's. So this is 5 minus 1. And then normal numbers with normal numbers. 7 plus 9 is 16, and booyakasha. Okay, again, we have a minus. So this is going to be f of x minus g of x. All right, so this will be a -6 and a -5. So think of those as being like minuses. And so the first order of business is x squareds with x squareds. So this will be 1 minus 6. Next are x's with x's. There aren't any x's over here, so the x's are just whatever that is. So that's -2. And then we have normal numbers with normal numbers. And so that is 1 minus 5. Okay, here we have f times g in this next problem. So f times g. And when we have a multiplication, okay, this is a multiplication in the middle, we have to do, people refer to it as the FOIL method, those sort of things. What you do is you take the first element of the first, and then what you do is you multiply it with everything of that next. So the first thing that we have to do is we have to take 5x times x. So 5x times x is 5x squared. And then we have to take 5x times -9. So that's -45x. All right. So what we do is we take that very first element, 5x, and we multiply it of everything of that next. So that would be the x and the -9. After we're done with that, what you do is you scooch to the next element of that first bit, and you repeat the process. So this will be 7 times x and 7 times -9. So 7 times x is 7x. 7 times -9 is -63. All that's left now with this problem that we now created is just to put the like terms together. So x squareds, there's only 5x squareds. X's are -45 plus 7, so that'd be -38. And normal numbers are 63, so that'll remain 63. So again, I know it's written a little bit different, but it's the same idea. This is f of x times g of x in number 7. So f of x times g of x. So what we do is we take the first element and we multiply it of everything over there, which is just a singular multiplication, no big deal. So 6 times 5 is 30, x times x is x squared. Okay, as soon as we're done with that, we move to the next element, which would be that -7, and again, repeat that process, which again is only a singular multiplication. -7 times 5 is -35, and there's a singular x there. All right, here we have some embedded functions and things like that. That means functions inside of functions and different stuff going on. Okay, notice that the idea here is blah, blah, blah is squared. Take a note what is being squared, and that is f of x. So what I just want you to do is take this f of x and put it where it's supposed to be. So this, in essence, is saying x minus 4 squared. X minus 4 squared. All right. Now, with this being said, do not be the silly, silly person that does this. Exponents don't work like that. This is absolutely not x squared plus 16. All right. If anybody answers it anywhere remotely close to that, I am going to laugh at you, and I'm going to laugh at your previous teachers because they did not do their job, or you're just stupid. All right. Don't do that. Don't do that. Instead, we know what it means for something to be squared. If something is squared, like this, whatever this is being squared. That means it's going to be that times itself 2 times. So it's that times that. So what that means in this particular problem is that will mean that x minus 4 is going to multiply itself 2 times. So this is a multiplication. You multiply by itself 2 times. So we start with the first thing, and we multiply everything of the next parentheses. So that'd be x times x and x times negative 4. Move on to the next item and repeat the process. So that'd be these multiplications right there. So that'd be negative 4 times x and negative 4 times negative 4, which is a positive 16. And then all we have to do is put the like terms together. So this is going to be x squared minus 8x plus 16. That's just sheer addition and subtraction stuff right there. All right, here we have similar problem, but this time notice it's the g of x that is being squared. So this is g of x squared, which is the same thing as saying 2x minus 1 times 2x minus 1. So we start with that 2x, multiply. So that's going to be 4x squared minus 2x. Move on to the next piece, which is the negative 1, and repeat that process. So that'll be negative 2x and a positive 1. 1 times 1 is 1. And then I combine those middle like terms of these negative 2x's. So this is going to be 4x squared minus 4x plus 1. And last but not least is this division problem. So here we have a g of x divided by an h of x. And I really doubt it if you're ever actually going to have to do these divisions. We might learn about it a little bit later in the semester. I'm not exactly sure. But for right now, pretty much all you have to do is just pretty much put in the polynomials where they're supposed to be. So for instance, the top is a g of x. G of x is x squared minus 25. The denominator is h of x. So h of x being 6 minus x. And with that being written, just kind of call it a day with that. Okay, and this is the end of assignment 1. Again, some of these problems might be exactly the same. Some of these problems might be a little bit different. But this covers all of the different types of problems. Again, some of the numbers might be different, but I bet you that they are done very, very, very similarly to how I've done these problems right here. However, if you do have big time questions and you're just unable to get your assignment done, or you're just stumped by a problem here or there, that's totally cool. I get it. Bring those kind of questions to class, and I would be happy to help you out. Okay, with that being said, this is the end of assignment 1 of Unit 0.